No, I don't. I turned off this. It's not any better when I turn this thing off. No. Last semester it was fine. The problem this year is that they moved this monstrosity in here. And I noticed that it was background noise because it's right next to the microphone. I don't have a. You're the first person, well, not the first person who said I need to be mic'd because of the background noise. Everybody usually tells me I need to speak more softly. I get it. This probably didn't help you. If you guys weren't so loud, I wouldn't. YouTube does put up closed captioning. I mean, if that helps, try it. They do a decent job of captioning it, but I reached an age, I don't know, probably 5 years ago, where I cannot watch TV unless I have closed captioning on. I don't know if it's my hearing or I watch too many shows where people speak with outrageous accents. So the captioning helps me pay attention, not pay attention, but understand what's going on. Certainly helps Dr. Who.
Yeah, but these don't wear glasses and you can't read closed captioning.
That, yeah. Well, I can't see the TV without glasses on, so there's so, yeah. Be able to wake up and see the alarm clock. Keep making TV screens bigger and my eyes just keep getting worse.
Right. That's supposed to help people, mainly for people in their 40s to 50s.
Hey, I'm still in my 50s. I'm still, if you round my age, I still round down to 50. I got another year of rounding down. Wait, no, I've got a few more months rounding down. All right, my wife rounds up to 60.
It's supposed to help people feel about life.
Huh.
I was like, 2 weeks ago.
I want that RK surgery that I could have gotten in the 80s where they basically would freeze the lens off on your eye, cut it off your eye, take it over to the side, and then cut little slices and then sew it back onto your eyeball. That was the before lasers. Now they just use lasers while it's on your eye. No anesthesia while you're awake.
My grandma had that.
Yeah.
Yeah, I mean, your eyes don't have pain sensors.
Exactly. There's no pain or something, no pain meds. It just don't freak you out. We watch a lot of procedural, medical, whatever shows. My wife can handle anything except when they go near the eyeball. She's out. No way. Okay. So make sure you read fall direction. That's going to be on all a reminder. Always simplify, reduce final answers to lowest terms. Simplify your fractions all the time. Write final solutions in the space when it's provided. There's no space here, so don't worry about that. You'll see it when it happens. No decimals unless it's in the directions. Show appropriate work to receive full credit. That's especially here. Work must be neat, legible, in appropriate boxes. So there's no scratch paper. I want to see all the work for question number 1 in the box with problem number 1, because I'm not going to go looking on some piece of scratch paper where you did number 5, then you did number 3, then you did number 7, then you went back to number 2, and you don't label which one is which. That's what happens to teachers. That's what you guys do that. So that's why I put them in boxes, and that way I can keep track of everything that's wrong. Remember quizzes, well, it should be done with pencils, so they may be easily erased. Should be, doesn't have to. I do have pencils if you need to borrow. Do not cross out or scribble out mistakes. Neatness always counts. The first one, just gotta write the equation on the line. Y equals mx plus b. So we have 2 points. Step 1, got to find the slope. Since we don't have the slope given to us, we've got to find it out ourselves. Difference of the y divided by difference of the x's. It doesn't matter which y coordinate you choose to start with first. You could start with this 4 or that -4. Doesn't matter. I'll start with this -4 minus that's +4 over this 7. If I start with this y, I got to start the denominator with this x. That's 7 minus that's 12. -4 minus 4 is equal to -8. 7 minus 12 is -5. A negative over a negative is a +8 over 5. That's the slope. So then, is that a special case? Is it 0? Is it undefined? No. So it's not just nicely x equals a number, y equals a number. And then we're going to write the equation in slope intercept form. We want y equals mx plus b. So when you're trying to put together a puzzle, you might want to write down what the puzzle looks like. We want to fill in the pieces. The pieces you're looking for are the slope and the y-intercept. We just found the slope. That's the first piece you plug in. We plug in 8 over 5. Y equals 8 over 5 times x and then plus b. Just got to figure out one more piece, figure out the b, and you're done. To figure out of 3 variables, to figure out one of them, you need to plug something in from the other 2. You're supposed to figure out b. So to figure out b, you need to plug something in for the x and the y. Well, you have 2 to choose from. This is an x and a y that's on the line, or that one's an x and a y on the line. It doesn't matter which one you choose. You'll get the same y-intercept because these points are on the same line. Has to. So just pick one. And this is where I usually see still, well, I don't know which one to pick. Well, just pick one of them. It doesn't matter. So which one should I do? Either one. Pick one of them. I'm not done. I'm not doing much spiel. So should I pick the first one if you want? Well, would it work if I pick the second one? Yes. Well, which one do you want me to do? It doesn't matter to me. It's up to you. It's like, they're afraid to cross the street. They know they have to get across the street, but they're afraid to take the first step. You're never going to go anywhere unless you just move. And they want to be told exactly what to do. No choice is left up to them. It doesn't matter which one. They both, you can plug them. Just don't plug in this X and that Y. That's not on the line. Which one do you want? So the second. Okay. So, and I tend, whenever, and what I do when I'm gonna grade your quiz, when I do the answer sheet, I will work the problem out with both. So I can grade the, somebody's work who chose the second point. I can grade somebody's work who chose the first point. I will figure out the slope. I use the -4 first in the numerator. I will also calculate the slope using the +4 first. So I can anticipate where the mistakes might be in partial credit control. So if I'm going to use 7 -4, that means I'm going to let x equal to 7 and y is -4. So we substitute -4 into the y equals 8/5. And we're plugging 7 in for x, so times 7 plus b. All right. -4 is equal to 8/5 times 7/1 is 56/5 plus b. Directions say no decimals, so don't make them decimals. And this is a habit. I don't know if you guys have it, because I haven't taught your level of class in terms of your level of student. I know Algebra 2 students, they don't like improper fractions. Their first thing is, I want either decimals, or they think they're going to need to put that in mixed number form. And I'm telling you right now, improper fractions, when you're doing your calculations, is where you need to be. If you're going to add, subtract, multiply, divide with fractions, you need improper fractions, just leave it. Why run the risk of converting it into a mixed number and making a mistake when you can just leave it as an improper, and you can just subtract 56/5 from both sides? But there's always going to be people that don't like fractions in the first place. So if you haven't seen this, I'll show this to you. If you have fractions when you're solving an equation, you can undo the fractions. And that way you don't have to deal with the fractions when you're trying to solve. Okay. Because if I subtract 56/5 from both sides, I got to get the common denominator, so I can do subtraction. The reason why you have a fraction is because of this denominator, 5. The denominator means divide by 5. Undo division. You undo division by multiplication. If I undo the denominator, I would multiply this term by 5. Now, here's what you need to do. If you multiply one of the terms by 5, you got to multiply every term by 5. Everybody gets multiplied by 5. It is exactly like you multiply the right side by 5 and distribute into the parentheses, and you multiply the left side by 5. But if you just say, I multiply one thing, multiply everybody, you don't have to worry about putting the parentheses and doing the distribution. Okay, whatever you do to one, so shall you do to all. So now this is -20 equals the 5 reduced, so you just have a 56 plus 5b. Now you've got an equation to solve that doesn't have fractions in it. Now it's a lot nicer to kind of work with. Subtract 56 from both sides. -20 minus 56 is -76 equal to 5 times b. And divide both sides by 5. So the y-intercept is -76/5. If you do it with fractions, you would subtract 56/5, subtract 56/5. So on the right-hand side, there's b. On the left-hand side, you're subtracting. You have a -4 minus a 56 over 5. So you have to get a common denominator. Common denominator is going to be a 5. Don't forget this first term is a negative. To make this denominator, which is a 1, into a 5, and then multiply by 5 over 5. So this -4 becomes -20 over 5. And then you have minus a 56 over 5. You have to make a common denominator to combine these together. There's the -76 over 5. Or you can undo the fractions and you don't have to worry about trying to work through the fractions. Okay. Final answer. The missing b that we needed needs to go right here. -76 over 5. So y equals 8 over 5x minus 76 over 5. That's the equation of y. Okay, so the first question today on your quiz, 2 points, slope intercept form, write the equation of y. Any clarification? Okay. Now, the second question is not 3 things, it's just one. You're just going to get one of these. I put up all 3 possibilities. I'm going to give you 2 linear equations, line 1 and a line 2. And the question is, determine whether the pair of lines, are they parallel, are they perpendicular, or is it neither? You must show appropriate work to support your. So if the lines are parallel, then the slope of the 2 lines are going to be equal to each other. Parallel lines have equal slopes. Remember, the word parallel has the 2 parallel L's. And if you turn the parallel L's sideways, it makes an equal sign. For parallel lines, slopes are equal. When the lines are perpendicular, the slopes are opposite and reciprocal. So you change the sign and it has to be a flip. If one is 2/3, the other one has to be -3 over 2, then the lines are perpendicular. Now, the perpendicular symbol looks like a vertical and a horizontal. They go in opposite direction, opposite. And a perpendicular symbol looks like a T that got flipped upside down. Oh, you flip it, that's what reciprocal means. Whatever it takes to remember those 2 pieces. Opposite and reciprocal. And then if the slopes are not equal and they're not opposite and reciprocal, so it's not parallel and it's not perpendicular, the answer is neither. Because if it's not A, it's not B, the answer must be C. Okay. The work that you have to show is compare the slopes. That's how you show. Are the slopes equal? Are they opposite reciprocal? Or are they neither? So for part A, every now and then they use some kind of, and it might just be water, but it feels like they use some kind of cleaner on the board. So the next day you come in and it doesn't erase them. Line 1, 3x minus 2y equals 38. Line 2 is 2x minus 3y equals negative 36. So the way you get the slope, how about the first question giving you a big hint? If you get y by itself, you know what the slope is. Y equals mx plus b, so that's how you get the slope. So to get y by itself, subtract 3x from both sides. Negative 2y equals negative 3x plus 38. And then everybody gets divided by negative 2. Negative 2 divided by negative 2, positive 1y equals a negative over negative is positive. This gives me positive 3 over 2x. Positive over a negative is going to be a negative. 38 divided by 2 is 19. So the slope of line 1, the slope of line 1 is positive 3 over 2. And then the slope of line 2. Subtract 2x. We have negative 3y equals negative 2x minus 38. And to get y by itself, everybody's going to get divided by negative 3. And we get y equals positive 2/3 times x plus 38 divided by 3. And the slope of line 2 is equal to 2/3. Are they equal? No. Are they opposite and reciprocal? No. They're reciprocal, but they're the same sign. They're not opposite. So that's not enough. So they're not equal, they're not opposite and reciprocal, so they're not parallel, they're not perpendicular. Line 1, line 2, this is a neither. And then the appropriate work is the slopes. This is your appropriate work. The slopes are not equal, nor are they opposite and reciprocal. Well, you could say right here, okay, not parallel, not, and you can even do not parallel, not perpendicular. Anybody know what those little 3 dots mean? Well, the word neither is right there. What do 3 dots mean? If I was saying, hey, here's my proof right here. So my conclusion here, we got not parallel, not perpendicular. Therefore, that is the notation for therefore. Even though there's only 3 dots, it means therefore. Therefore, it's neither. So you can write it out just like that. Okay. But yeah, that's the symbol for mathematical symbol, or even, I don't even think it's mathematical. I think it's an actual literary thing. It's shorthand for therefore. Yeah. Line 3, line 4. So line 3 is 3x minus 2y equals negative 38. And line 4, 38 plus 3x equals 2y. Okay, the nice thing about part A, they were both written in standard form. No, basically no tricks, no misrepresentation. On line 3, standard form, ax plus by equals c. But line 4, okay, things are getting mixed up a little bit, and that can be expected. So we compare the slopes. Subtract 3x. Subtract 3x, get y by itself. We end up with negative 2y equal to a negative 3x minus a 38. And then everybody gets divided by a negative 2. So we get positive y equals a negative over a negative is a positive. 3 over 2 times x. A negative over a negative is a positive. 38 divided by 2 is 19. So the slope of this line is 3 over 2. The slope of line 3. And then remember, you're just trying to get y by itself. What does y equal? Well, this one is just 2y equal to this over here. You're basically ready to get y by itself. To get y by itself, you just have to divide everybody by 2. Now it's on the, it's not the wrong side, it's just on the right side. We'll flip it at the end. 38 divided by 2 is 19, plus this is 3 over 2x. So that causes, a little bit of dizziness when you're trying to match it up with slope-intercept form, then just trade places. If this is equal to y, then y is equal to, and then put it in the right order, mx plus b. It's a positive 3 over 2x, and that's a positive 19. So the slope of line 4, the fourth slope, is 3 over 2. Slopes are equal. So line 3 is parallel to line 4 because the slopes are equal. Well, that's because I'm an idiot who didn't put and make sure that the y-intercepts came out different. They are technically the same line. Yes, they are. In mathematically, we would say these two lines coincide. Because when you say parallel, they don't intersect, which means they have no points in common. Because they are the same slope and they go through the same point, they have every point in common. It's kind of hard to be parallel when you are the same line to itself. And that's because I didn't change the 38, because I was doing this a little bit late at night last night. And I'll tell you right now, I was trying to work this out. I'm not looking for any sympathy, trust me, I'm not. I was in so much pain. I just had one equation left to finish. And I couldn't think straight because the pain was so much in my legs and in my back. It took me an hour and a half to finish not one quiz or one question. To figure out one question, I messed this one up at some point. I couldn't concentrate. That's how much the pain messes with the brain. But the slopes, let's pretend this was a 40. A 40. Oh, yeah. 40, yeah, 40. Oh, that's wrong one. 40, so 20. Close it. There we go. Good catch. No, I don't, again, I'll look for some. If I can't get it from my own family, I'm not looking.
I was paying attention to the other one. So, like, let's say, like, for the last one, both of them, D equals 19. So D, is that what you guys are talking about?
Yeah, they came up with their.
These are different,
So-
that's just the intercept, that doesn't mess with like whether they're parallel.
Well, because they both have the same slope and the same y-intercept, they technically are the same line. You can't be parallel to yourself. So this is a horrible example because I messed up with my number.
Yeah,
But
but like even if the D is different on both of the lines, we're just looking at the slope.
yes, that's all we care about. Are the slopes equal? We got parallel. Are they opposite reciprocal? We have perpendicular.
And then.
For right now.
And then if you wanted to like graph it, would we just start from the origin? Is that cool?
You start from the origin to find your y-intercept, and then from the point you just labeled on the y-intercept, then you count your slope. Yeah. All right, the last one. Move that up a little bit.
So was line 4 the only one that was wrong?
I think so. Let's figure this one out right here. I think so. I think I did a C okay. I think I was trying to basically power through the part B. And I didn't think twice about it. And then the one that took me an hour and a half was figuring out the nice numbers for this one. Let's see. Fine. 96 minus 8y equals 5x minus 6, 8x minus 60y equals 60 equals 5y. Getting this y by itself, you got to put 96 on the other side. You subtract 96. And we end up with negative 8y equals positive 5x minus 96. And then everybody gets divided by, don't forget that's a negative 8. So y is equal to positive over negative is a negative 5/8 x plus negative over negative. 8 goes into 96, 12 times. So the slope of this line, slope of line 5, is negative 5/8. Sure. This one, we want y by itself, so the only thing happening to y over here, 5 times y. So we're going to divide everybody by 5. Everybody gets divided by 5. So that gives me y by itself, like I've been trying to get. 8/5. X minus 60 divided by 5 is 12. So from left to right, y equals 8/5 times x minus 12. And the slope of line 6 is positive 8/5. So the two lines, are the slopes equal? No. Are they opposite? Okay, yeah, they're opposite. Are they also reciprocals? Yes. So these two lines, line 5 and line 6, line 5 is perpendicular to line 6. because the slopes are opposite and reciprocal, and just showing that you've got opposite and reciprocal slopes is what is the work that you show. Okay. So I guess I will do that where I wrote on. The good news is if I messed up the one I wrote on the quiz, it would should at least come out with the mean. Yeah, we'll come out. No. I'll double check before I give it to you about the phone side. Any question about your warm up? That's exactly what's going to look like. All right. Any questions from homework 1.2? Okay.
How many tissue on the gym?
Tissue, no, don't. There's those hand sanitizer. Wet naps over there that come out of that. Yeah.
Thank you.
Introducing functions. Conjunction function, once your and math has evolved from just counting to drawing pictures in the sand to it wasn't until the 1800s there was no equal sign. This is what they use for equals instead of an equal sign. Then somebody said, hey, how about, and put two lines sideways. Oh, that's so much better. Because you know how long it takes time? And then you only have three dots there. Are you saying therefore? Because you only have three. Wow, that's you should have people. Functions revolutionize how we approach mathematics. Looking for equations that represent real world. And you get basically ordered pairs. You get data. Data where you can relate one piece of information to something else. And that's what your entire world right now basically revolves around, collecting data. It's all about statistics. Everything these days is about statistics. Well, statistics is about being math driven. It's about graphing, and you can't graph unless you have ordered pairs. Every set of ordered pairs, no matter what, is a relation between the X value and the Y value. There is some relation that holds them together. Maybe it's an equation. Maybe it's just some random occurrence. What we hope is that there's some kind of an equation that connects the X and the Y together so we can make predictions about what's going to happen in the future. But the bottom line is it's about collecting data, something for X, something for Y. And most of the time it's about collecting data with respect to time and how something else might change, like money or population or disease or health or food growth or whatever. Okay. Total number of male students in the university, and then compare that on the y-axis to the total number of male students that actually graduate from the university. collecting two pieces of information, and that's a relation. There are special kinds of relations of ordered pairs, X's and Y's, that take it one step higher. So you have ordered pairs, two sets of values. They're always relations. Anytime in an ordered pair, that's a relation. Special relations take it up one notch and they become functions if they satisfy one very important piece of information. So let's get into the terminology. It's all about how things are defined. I'll say this more than, just the 15 times I've already said it this semester. Math is a language, and what has happened from the year 1200 to where we are now is the language has become more specific. And one of the students stayed after yesterday, and we talked for a while, and about basically the Monday, Wednesday class is behind you because of the day off last week. But he was putting some of these pieces together and he's asking questions like, is it always like this? And I said, yeah. And I said, it's like this because of the way it's defined. No matter where you are, it will be like this for whoever's doing it, because that's how mathematics works. It works on truth. Whatever we do here will be done somewhere else because it's based on this truth that has already been passed down and is repeatable. Because if it's not repeatable, it can't be math. They, mathematicians agreed on this. So you can't just do it, your way, my way. The answer has to be the answer. You can get there different ways, but you cannot just change algebra and the rules that govern the algebra. Everyday phenomenon involving two quantities that are related to each other by some rule of correspondence. The mathematical term for such a rule of correspondence is a relation. They're related to each other in some way. Two examples. Simple interest on an investment for $1,000 per year is related to the annual interest rate formula, I equals 1,000 times R. So you invest $1,000, you're getting so much interest on that $1,000. How much money you earn at that rate is 1,000 times the rate. Okay. How much money you earn, that's the output, is dependent upon what you plug in for the rate as your input. The area of the circle is related. The area A is related to the radius. You increase the radius of the circle, you increase the area of the circle. You decrease it, you decrease the area. They're related to each other. Those formulas relate the radius to the area. They relate the interest rate to the value of the interest. Relation. Okay. Not all relations have simple math formulas. You can match an NFL starting quarterback with touchdown passes and the time of day with temperature. Okay. In each of these cases, there is some relation that matches each item from one set to the other. Wait. I'm glad to show it. Not all relations have simple mathematical formulas. I get that, okay? For instance, you can match NFL starting quarterbacks with touchdown passes and time of day with temperature. I'm going to, I'm sorry, that paragraph, I'm not exactly sure what he's trying to get across.
I think you have to separate NFL starting quarterbacks with touchdown passes and time of day. I think they're using two different examples for that.
I know they are, but I'm trying to make it connect to what they are trying to say at the beginning, the for instance part. And it doesn't connect for me, so I'll talk about it in a minute. Okay, so here's math speak. Hello, math. A function Special relations are functions. Special relations are functions. Every ordered pair is a relation. Special are functions. Here's what makes a relation a function. A function f, lowercase f, kind of strict looking f. This is not a variable. This is the name kind of f. Not a variable. It's the name of the function. Freddy, that function's name is Freddy. You can have a function in Freddy. You can have G, Guido, Hugo function, h of x, f of x, okay, g of x. In calculus, position function is s of t, velocity is v of t, acceleration a of t. Position of an object, velocity of an object, acceleration of an object with respect to a time t.
What was the
They're just names of a function. So you would have f of an x, g of an x, h of an x. When we start to include the variable x. But the f, the g, and the h are not variables. They're the names of the function because the function notation, the f, the g, and the h, are there to replace y. I'm not asking a question. They're there to replace the letter y. So instead of having, if you have three different things you're trying to graph, and you have y equals this, y equals something else, and you're graphing all three, which y is it? Well, the first one is f of x. The second one we're going to call g, and the third one we'll call h. So now you can distinguish between which one is which. And that didn't happen until 1700 with Leonard Euler. Right? On your test. A function f, so this function f, from set A to set B. Set A. We're dealing with numbers. Right. Sets. And that's what functions are. It takes values, elements in one set, and it pairs them up, matches them up with elements in a second set. So a function takes something from over here and matches it to something over there. A function f from set A to set B is a relation that assigns to each element x in set A exactly one element y in set B. This is why, again, trying to help you learn how to decipher mathematical writing. The set A is the domain or set of inputs of the function f, and the set B contains the range or set of outputs. Okay. Sets. You're going to plug stuff into a function. You're going to plug numbers in or whatever you're told to plug in, you're going to plug them in. Whatever you're plugging in, that's the input. What you plug in is input. What comes out is output. Goes in is input, what comes out is output. What goes in is the domain. What you plug into a function is the domain. What comes out is the range. What comes out of a function is the range. What goes in is domain, and what comes out is range. Domain and range. Alphabetically, D before R. D is first, range is second. Alphabetically, X's before Y's. The domain is the X values that you're plugging in, and the range is the Y's that come out. Domain and range. Okay, that's what they're saying right here. It assigns to each element X in the set A. The domain is set A. One element Y that's in set B. The Y is part of the range that's in set B. Okay. And they use this nice little illustration. To help understand this definition, look at the function that relates the time of day to the temperature. Here's our domain. The time of day in PM, 1 p.m., 2 p.m., 3 p.m., 4 p.m. So the set of times is in this box over here. That box, is the visualization of, this is a set of things. A set of things is kind of like, here's a bag of numbers. Here's a bag of things. In this bag is what I'm going to pick out of and plug into my function. This is what I get to choose from to plug into. What comes out are the temperatures. When I reach into the bag of time and pull out 3 o'clock, I will pull out the temperature that corresponds to the 3 o'clock. When I plug in 3 o'clock, I will figure out what temperature it is, because there's a direct correlation from time of day to temperature. So 3 o'clock will give you 15 degrees Celsius. Also at 4 o'clock, it's 15 degrees Celsius. At 1 o'clock, 9, 2 is 3. 3 and 4 is 15. At 5 o'clock, it starts to cool down. At 6 o'clock, it's 10. The domain is a list of the inputs. The domain is this set of all the x coordinates. And the range is the set of all the y coordinates. Now look at the y's. 9, 10, 13, 9, 10, 12, 13, 15. Do you see how 15 degrees Celsius happened twice? At 3 o'clock, it was 15 degrees Celsius. At 4 o'clock, it was 15 degrees Celsius. Do you see 15 degrees Celsius written twice? No. We have 1, 2, 3, 4, 5, 6 different times over here. The domain has 6 different values, but the range only has 5 temperatures. That's perfectly fine. And that's because one of those temperatures occurs at 2 different times. If it's a function, you know what's impossible? It's impossible for 5 o'clock to be 12 degrees Celsius and at the same time 5 p.m. to also be 9 degrees Celsius. It's impossible for 5 p.m. to have 2 different temperatures on that same day, in that same place, at that same time. If it's a function, here's the definition. All sets of ordered pairs are relations. And that's what you have. You have sets of ordered pairs. At 1 o'clock, 9 degrees Celsius. At 2 o'clock, we have 13 degrees Celsius. At 3 o'clock, we have 15 degrees Celsius. At 4 o'clock, we have 15 degrees Celsius again. At 5, we have 12. And at 6 o'clock, we have 10. A set of ordered pairs. So it's a relation. The reason why this is a function is because the domain never repeats itself. In order for a relation to be a function, special relations are functions. If the domain doesn't repeat, you're a function. If the domain happened in 2 different ordered pairs, you cannot be a function. So, if for some reason at 1 o'clock it's 9 degrees Celsius, and over here at 1 o'clock it's 13 degrees Celsius, make up your mind. At 1 o'clock, are you 9 degrees Celsius or 13 degrees Celsius? The domain value, the x value, cannot happen and give you 2 different y values. When you plug in 1 for x, only 1 y value can come out if you are a function. When you plug in something for x, you get only 1 answer for y. Only 1. So when we plug in 1 o'clock, we can only have 1 y value. Now, y can repeat. You can get multiple y's. Maybe you're at the equator. No, sorry, that's There's no place where the temperature stays the same the whole time, so never mind. Bad example. Okay. Unless you're standing on the moon in the sunlight and all day long, it is like 272 degrees Celsius, or not Celsius, but Fahrenheit. If you're standing in the sun on the moon because there's no atmosphere, 1 o'clock, 272 degrees Fahrenheit, 2 o'clock, 272 degrees Fahrenheit, Celsius, Fahrenheit, 3 o'clock, 4 o'clock, 5, every Y value would be horizontal line. But it's a function, no matter what the time is. All the times are changing, they have the same Y value, that's perfectly fine. You just can't have 1 o'clock be one number and then 1 o'clock be something else. The X can't repeat what Y can. That's what defines our function. Every set of ordered pairs is a relation. Special sets of ordered pairs where the X does not repeat is a function. Okay, the X's are the domain, the Y's are the range. So characteristics. Each element of A must be matched. So every element of A, every X value, that's the elements of A, all the X's, must be matched with something in the range, must be matched with some element in B. So every X value that you have in the domain has to have some Y that goes with it. If you're in the domain, you got to have a Y value. Okay. Some elements of B may not be matched with any element of A. So there might be some Y values that don't have any X values. Some elements of B may not be matched with any element of A. That's okay, perfectly fine. It's about X, not the Y. In order to be a function, X can't repeat, and every X you have has to have a Y that corresponds to it. 2 or more elements of A may be matched with the same element of B. So it's like 2 guys can date the same girl, okay, but 1 guy can't date 2 different girls. That's not right. So a girl can go out with as many guys as she wants, but the guy can only date 1 girl. Okay. And an element of A, the domain, and that's exactly what I just said. An element of A cannot be matched with 2 different elements of B. A cannot have 2 different Y values. X cannot have 2 different Y's. But Y can have 2 different X's, or as many X's as it wants. So, just a simple example, determine whether the relation, so you have X's and Y's, X, Y, X, Y, X, is it a function? So A. X is 2, Y is 11, X is 2, Y is 10, X is 3, 8, 4, and 5, 5, and 1. Is that a function? No. Because when X is 2, 11, but then now when X is 2 is a 10, not a function. That X can have 2 different Y's that go with it, not a function. And then here, looking at this scattering of points, is that a representation of what a function would look like? Yes. Now hold on a second. What do you mean just by looking at it? So a little something called the vertical line test for functions. A picture of any kind of graph is a function if a vertical line intersects it in at most 1 point. At most, so no more than 1. Now, could it be 0? Sure, that's fine. But at most 1. If I were to draw a vertical line at this point right here, then this vertical line intersects that point, and there's no other point on the vertical line. There's only one point on this one. There's only one point. There's nothing above or below. Nothing above or below. In other words, this scattering of points right here for this one, x is -2 and y is 3. There's no other point that has x as a -2. If there was another point that had x as a -2, like negative right here, it would have to be directly below it or directly above it in order to have the x repeating itself. Directly above it or directly below it. So if you don't have anybody above you or below you, you're a function. Because if you have somebody above or below, x repeated, and if x repeated, you're not a function. X cannot repeat. That's a no, and that's a yup. Testing algebraically. Algebraic. X squared plus 1, or x squared plus y equals 1, versus negative x plus y squared equals 1. So the way you do this algebraically, solve for y in terms of x. Solve for y. So if I solve for y, subtract x squared, I get y equals negative x squared and then plus 1. Now, if I pick an x value, like a 4, when I pick 4, this is a single y on this left side. When I let x equal a 4, only one y value is going to come out. Y is going to equal negative, and then 4 squared plus 1, so that y is going to equal negative 16 plus 1. Y is going to be a negative 15. There's no way for me to get two different y values if I square something, put a minus in front of it, and add 1. There's no way I'm going to get two different y values. If I got two different y values for this x that I plug in, you're not a function. So y equals negative x squared, function. This one. When I solve for y and x, y squared equals x plus 1. And we take the square root of both sides to get y by itself. This y value, remember we're solving, plus or minus the square root of x plus 1. So now, you have two possible answers. You have two possible answers for y. You have negative square root x plus 1, and you have y equals positive square root x plus 1. So when you let x equal 3, we get y equals negative square root x plus 3, put 3 plus 1. Plug 3 in for x. So y equals negative square root 4, we get y equals a negative 2. So when we plug in positive 3, we get negative 2 here. And over here, when you plug in 3, we get square root 4. We get positive 2. Over here, when you plug in 3, we get positive 2. 3 goes in, negative 2. 3 goes in, positive 2. You can't get 2 different answers for 3. Only one answer if you're a function.
Where did you get the numbers that plug in?
I picked, so I chose wisely about, I know I got to take the square root. So I want to take the square root of a perfect square. So what plus 1 is going to give me a nice perfect square? Square root 1, square root 4, square root 9. So what would make a nice square root 4? X would be a 3. That's why I chose it.
So it's just like whatever works best to.
Yeah, because I'm taking the square root.
And then what about the other one?
Well, here, it doesn't matter what I plug in, so I'm going to square it, not square root. Squaring a number is really simple. Square rooting, the only square root comes out to be decimals unless you have perfect square. So it's like,
It's just plugging in. Like, where you want for that one.
yeah, so if you, 0 squared, 0, 1 squared, 1, 2 squared, 4.
He's just like choosing random.
Yeah, I'm not going random, I'm thinking, so it's technically not random as opposed to choosing cautiously. Over here, if I plug in 100, it's going to be just a single answer. If I plug in -3, I'll get a single answer. I can pick anything I want. I'm going to get one y value for that x. Over here, there's problems. And right now, we're not going to get into the problems that are coming in a few minutes. But I had to take the square root of a number. So I had to pick an x after I had 1. That would work out as a nice answer. So something plus 1 that equals 0, 1, 4, 9, 16. So the square root of those are nice answers.
So when you have like the answer in like y equals whatever for either one of those, how would you, what exactly is making that determine that?
So right here, because when I solve for y, I had to take the square root of both sides. When you take the square root of both sides, you are solving this equation for y. So this, whenever you're solving an equation, you have to put plus and minus. Okay? So the answer for y is negative square root x plus 1 and positive square root x plus 1. So when I plug in 3, I have to plug it into both of those possibilities. Okay. In other words, if I started right here and I plug 3 right in here, -3 equals plus y squared equals what? Plus 3. Y squared is equal to 4. So y could equal plus or minus a 2. So the 3 that I plugged in could give me a -2, or it could give me a +2. So when x is +3, I get 2 possible answers for that y. And since x cannot have 2 different y values, that's not a function. Okay? Getting ahead of ourselves, let's do this. Remember how we just said that, I kind of let the cat out of the bag on vertical lines. If points stack one above the other, you can't be a function. Okay. When you have x squared and y to the first, this is a parabola. And if the x is squared and y to the first, the parabola either opens up or it's going to open down, depending if it's a positive x squared or a negative x squared. Okay. When it's x to the first and y squared, if the y is squared, that parabola is opening sideways, left or right. And if it opens left or right, guess what? You are now failing that vertical line test because that vertical line intersects the graph in more than one place. And you are not a function.
I was just like more confused because like I know it's like y equals whatever the answer may be, and I guess it's kind of like checking your work. Like if you plug that into the original equation, it's supposed to equal that, and that's what it is. That's what I was having a hard time.
Okay.
realizing, but plugging in like whatever number you plug in, I guess maybe checking your work is like.
Well, and I just basically was coming up with, all right. Right here, you know, what do you do if you had to do this on your own? Reading the book. Here's an example of what I'm gonna have to do. Let's read through the example. Working this through algebraically, it said solve for y. So we solve the first one for y. When I get y by itself, I get single y equals. Just one answer, y equals this. So whatever I plug in for x, I'm only going to get one number. No matter what I plug in, I'm not going to get a, when I plug in x, I'm not going to get two different answers for that one x that I plug in. There's no way. Because there's no possible way to get two different answers. But here, because when I plug in an x, I'll get a positive answer or a negative answer for that value, whatever I plug in. I'll get two different answers for the x that I plug in, for the y value. So whatever I pick right here to plug in, I'm going to get a negative square root of 1 plus x, and I'll get a positive square root of 1 plus x, because that's what this y ends up equaling when I solve for it. Since there's two possible values for y for that one x that I plugged in, not a function. That's what it means by showing the work algebraic. Okay. That's what it means by showing the work. So maybe it only, when I plug in 3, well, what if it's like 3 is just an anomaly? What if it's some, all the other numbers are fine? You can't just plug in all the numbers. This is what they talk about by showing it algebraic. When you solve for y, do you get two possible answers? That's what you're doing. Okay. Okay, we usually like write down here this other example. If you got this y squared by itself, when you solve for it, you would take the square root of both sides. You would have to have a plus and a minus. That means when you plug in x, you're going to have a plus and a minus as a possible y value, therefore not a function. But over here, y to the first. So when you get y by itself, you're only going to get one answer for y. It just equals that right-hand side. You're not going to get two possible answers. So this one would be a function, and this one would.
Because it's negative.
No, this one is because it's y to the first. So if I get this y by itself, y is going to equal, add 4x to both 4x squared to both sides. 4x squared plus 36.
Oh,
I'm not
you
getting
wouldn't-
a plus and minus anymore. I'm not getting y equals plus something minus something. Over here, this y squared would equal 8 minus x squared, take the square root, y equals plus or minus square root 8 minus x squared.
So even if like the y, like let's say it was x squared minus y squared, if the y was negative, you wouldn't like have just the square root, like a negative square root. It's
So
always positive.
if this was a square, you know what you're saying?
But like there's like it's a negative y.
That's a negative one. So they're both negative?
Yeah. So
If they were both negative, then I would divide by -1. That would be negative. So these two would be positive, and that would be impossible.
You would always have like a positive square root.
Yeah. There's a lot to do with the x part. Yeah. Definitely. X, see, like x squared is always even powers. Even powers tend to look like this, x squareds. X to the fourth are a little bit more shallow. Or an x to the fourth might look like this. Whoops. And an x to the fourth would look like this. Odd powers, that's an x cubed. Or this could be an x cubed. And in section 1.4, we're going to tell the difference between odd and even, what they look like. The even, you see how it is pointing up? Even, the other side points up. X to the fourth, up, up. This is X to the fourth, you know why? Because if that was the x-axis, it would cross the x-axis 4 times. Okay, but off, since it's even, if this one's pointing down, and even the other side would also have to be going in the same direction, pointing down. Odds go opposite. If you're an odd function, one side's down, the other side's up. Even if you're x to the third, 3 solutions. One side down, the other side's up. X to the fifth, one side down, the other side up. And whatever happens in the middle happens in the middle. Okay, they behave this way because that's their nature. Okay. Functions make our life easier. So for substitution, what you used to have would be a given equation, y equals something, and you would have to make a whole bunch, here's the position of an object flying through the air. S of t is equal to, let's just go negative 16 t squared plus 482 t plus 126. That's a position of an object launched 482 feet per second from a height of 126 feet. And that negative 16 is 1/2 the gravity constant in feet per second squared. And they would say, all right, what is the height? Find the height. Find position at, or my bad. Function notation wasn't around. The height of an object. Find the height. At t equals 0, t equals 2, t equals 3, t equals 3.5, t equals 3.9, t equals 3.99, t equals 4. And you'd have to make a whole bunch of substitutions. And so you would start meticulously. All right, let t equal 0. And then h equals, plug it in. Let t equal 2. And then plug it in. Let t equal. So function notation comes along. Instead of h equals or y equals, they replace whatever you're measuring on the vertical axis with function notation. Position is, and I don't know why they use S, but they call it S of t. The position of an object, S of t. So find the position, S of t, at those times. So now it becomes this, the substitution is a little cleaner, a little easier to work with. You're just going to do S of 0. S of 0 means if I replace this t right here with a 0, then every t in the equation gets replaced with a 0. Negative 16 times 0 squared plus 482 times 0 plus 126. So S of 0 equals 0 plus 0 plus 126. So S of 0 is 126. And then S of 2. So instead of going through that whole let t equal and then do it over and start over. If I replace this t with a 2, then all the t's become a 2.
negative 16 times 2 squared plus 482 times 2 plus 126.
And it's a lot easier to work with. Plus in function notation, instead of writing out the actual equation all the time, if I actually want to write out what the answers are, and I want to, all right, what is the answer for 4 seconds minus the answer at 3 seconds? Well, instead of plugging all that in, I would just say, what is S of 4, the position of 4 seconds, minus the position of 3 seconds? And I can write it out using function notation. The position of 4 seconds minus the position of 3 seconds. We can also using function notation, because now it's written in terms of here's the name of the function with respect to a variable. And that's kind of what this also represents is S of t. Function S with respect to variable t. So the name of the function is S, and the variable that you're plugging in is t. What is S of, oh, let's go S of B? Well, that gets people. All that means is, if this is what it looks like when T is plugged in, replace the T's with B's. If I replace that T with a B, all the T's get replaced with B's. Negative 16 B squared minus or plus 482 B plus 162. I keep alluding to calculus because that's, some of your goals. The derivative of a function, f prime of x. When you take the instantaneous slope of any function, it's equal to the limit as delta x approaches 0 of f of x plus delta x minus f of x divided by delta x. What do? You plug that into whatever f of x is. You plug it into the function. You plug x plus something delta x, wherever that delta x means. And then you subtract whatever f of x is. And then you divide by delta x. Little bit at a time. And that will give you the slope at any point, anywhere on the graph. You guys will do a little bit of this without the limit part. It's called a difference quotient. So function notation allows us to work with multiple functions at the same time and make substitution much more manageable. Not nearly as tedious. I will give you some huge advice. Please, when you substitute, parentheses to be your best friend. Use parentheses. Right there, example 3. So they give us g of x, function g, we know, function g of x is equal to negative x squared plus 4 times x and then plus 1. Part A, what does g of 2 equal? So if I replace this x with a 2,
then all the x's get replaced with 2's. So g of 2 goes in, I get negative, and then I have a 2 squared, and then plus 4 times 2, and then plus 1. And right here, I will see the same mistake I keep telling students not to make. So g of 2 equals, what's this, negative 2 squared? That's the mistake people will make. What is it? What is this? Negative 4. I know, hey, wait a minute, this is being squared. Yeah, the 2 is not the negative. Right here, it's negative and then x squared. The negative is not in a parenthesis, only the x is squared, not the negative. So when you plug in a 2, you're only squaring the 2, you're not squaring the negative. If you're to actually write it out in, using longhand, it'd be negative, that one, and then you have a 2 times a 2. There's only one negative. It's not a negative times a negative. If you wanted negative 2 times negative 2, you'd have to have the negative in a parenthesis. And it doesn't have one. So this is why I said parentheses are going to be your best friend when you make substitutions. I have a negative, and it doesn't hurt to go a negative, and then I'm only squaring the 2. So you see exactly what you actually square. Negative, I get 4. Plus 4 times 2, that's 8, and then plus 1. So g of 2 is just positive 4 plus 1, we get a 5. And then if they want you to write the answer as an ordered pair, you write it as it was an x, so x is 2, ordered pair, y is a 5. Or if they want you to leave it like this, you can leave it like that. And then here comes B. It's like, okay, wait. G what? G of T. Well, this is what G is defined. Function G says, no matter what you plug in, minus, you're going to square it, plus 4 times it, and then 1. If I plugged in 2, it's going to be minus the 2 squared, plus 4 times 2, plus 1. So when you plug in a t for x, it's just going to be a minus, and then you square the t, plus 4 times t, and then plus 1. And that's as much as you can do with it because it doesn't simplify. That's as far as it goes. Replace x with a t. My first, educational thing at UCLA when I was, right out of high school, they had this summer program where we got 7 weeks at UCLA away from the families before school actually started. We took 2 classes, got to live in the dorms, and it was free. Thing is, we got to go UCLA party for 7 weeks. Took a math class and a computer science class. The math class, I don't even remember the professor's name, but I remember the TA. It was Matt, Daisy, and Ron. Because we had to see them, I think it was 3 days a week. And Matt would explain functions. I remember how he explained it. He was like, he would wear these shorts all day. He was coming from the surf because he's barefoot all the time. And it's like, well, if you want to plug in like happy face, then it would just be negative happy face squared plus 4 times happy face and plus 1. No matter what you put, just replace a happy face. Oh, that's what substitution means. No matter what that x is, it gets replaced with whatever you're replacing it with. I wish they would have said that last year. Because now you got to do g of x plus 2. So instead of a happy face, Instead of an X, replace it with an X plus 2, an X plus 2, an X plus 2. So that's a negative. X was squared, but now it's a X plus 2 squared. It was 4 times an X, but that X is now a X plus 2. And then a plus 1. Whatever this is, you replace it with whatever you're told to plug in for. Your first step is write it out. Don't try to plug it in and at the same time work it out. Write it out and then work it out. Okay? When you try to do things in your head, that's where the mistakes happen. You'll write down things that don't even have any business meaning. So we'll pick that up on Tuesday. And here comes the quiz. This is also how I'm taking a roll. If you don't turn in the quiz, you weren't here. There's a little half sheet of paper. Please put your first and last name. You know, if I have like, 3 Phillips, which Philip are you? Open note or whatever you want to open, just no internet devices and you don't have to graph anything unless that helps. I'll have these back to you on Tuesday.